All right, we're going to go behind the scenes of some of the most advanced cars out there to look at a totally new safety rulebook. One that's all about the really complex partnership between a smart car and you, the driver. Let's get into it. So think about this for a second. It sounds a little like a riddle, right? But this is the exact question that car safety engineers are wrestling with right now. And it really pushes us to think beyond just system failures and face a much more subtle, hidden kind of danger. And that, right there, is what this is all about. The solution isn't just about throwing more tech at the problem. No, it's about designing a system that actually understands its own limits and knows how to manage a safe, clear relationship with its human partner. So, to really get our heads around this new way of thinking, we first have to understand that the whole nature of risk in our cars has completely changed. I mean, we are dealing with a whole different ballgame of problems than we were even just a decade ago. Okay, so the industry's answer to this is a standard called SOTIF. The easiest way to think about it is as a safety code for when everything is working exactly like it's supposed to. So it's not about preventing a breakdown, it's about managing the known limitations of even the most sophisticated systems. Now, what's so interesting here is how clear the difference is between old and new safety. Functional safety, the old way, was all about what happens when a part breaks. A sensor just dies or the code crashes. SOTIF, on the other hand, deals with what happens when a perfectly good sensor simply can't see through a massive downpour. The system hasn't failed, it's just hit its performance limit. And that right there is a massive shift in thinking. And that big difference brings us to one of the most critical, nail-biting moments in driving today, the handoff. This is that moment where the machine has to safely pass control back to the human. You really got to think of it as a carefully choreographed handshake. A key rule in this handshake actually comes from a regulation called UN R157. It says the car has to give the driver a minimum of 10 seconds to take back control. So, why 10 seconds? Seems specific, right? Well, that's what's considered the bare minimum time for a person to stop what they're doing, get their eyes back on the road, figure out what's going on, and actually be ready to drive. So how does the car actually get your attention? Well, it pretty much uses every sense it can. It's a full-on sensory experience. You'll get visual cues, like the lights on the steering wheel of a Mercedes, flipping from a calm blue to a flashing urgent red. You'll hear chimes that get faster and louder. And you'll get physical haptic feedback, like a buzz in the wheel or even a tug on your seatbelt. It's like a literal tap on the shoulder saying, "Hey, I need you, now." You see, a good handoff isn't just a command. It's more like a quick conversation. The best systems don't just tell you what to do, they tell you why. Knowing you need to take over because of bad weather gives you the context to react the right way, instead of just being shocked by some sudden, random alarm. Of course, even the best handoff system in the world can't always predict human behavior. And that brings us to the next massive challenge. How do you design systems that can anticipate and even prevent us from using them the wrong way? And this quote it absolutely nails the heart of the problem. A system can be technically perfect, but if it's super easy for a driver to misunderstand it, trust it too much, or even deliberately cheat it, then it's just not a safe system. So, to fight this, engineers have this kind of three-layer defense. First, it starts with education. I mean, even just calling a system drive assist instead of autopilot sets much more realistic expectations. Then the car is constantly monitoring you, using interior cameras to track your eyes and make sure you're paying attention. And finally, if all else fails, it intervenes. If you ignore too many warnings, the car can just lock you out of the feature for a while, like what Tesla does with its suspension policy. And this monitoring tech is getting incredibly smart. Early systems just checked for turning force on the wheel, and people easily fooled them by hanging a water bottle on it. But the newer systems, they use sensors that can actually feel the touch of a human hand, or they have algorithms that recognize the weird, steady pressure of a cheater device and will sound the alarm. But what happens when everything fails? The driver's asleep or having a medical emergency, and that partnership between the human and the machine just completely breaks down. There has to be an ultimate safety net. This is the big one. This is the critical question that every single one of these advanced driving systems has to be able to answer. If the car has sent alerts and it's escalated the warnings, and it gets absolutely zero response from the driver, what's its next move to protect everyone inside? Well, there's a clear automated process that kicks in. It starts with a simple request: lights and sounds. No response, it escalates. Warnings get more intense. It might even use a sharp little brake jerk to try and startle the driver awake. If that still fails, it triggers the last resort. The car turns on its hazards, slows down to a safe stop, unlocks the doors, and automatically calls for help. This whole sequence, this emergency plan, it has a name. It's called a minimum risk maneuver, or MRM. It is the car's pre-programmed plan to get itself and you to the safest possible state when the driver is totally out of the loop. It is the final and, honestly, the most important layer of the safety. So you have to realize that this whole new approach to safety isn't some one-and-done checklist. It's a huge shift in thinking. It's really the start of an ongoing conversation between engineers, regulators, and, yeah, us drivers. A huge takeaway here is that safety is now treated as a life cycle. These cars are literally designed to learn. A lot of them use something called shadow mode, where new software runs in the background. It makes decisions but doesn't act on them. It's like a student driver, letting engineers test its judgment over billions of real-world miles. And when a real critical event happens, like a sudden handoff or a near miss, the car logs everything. And all that data gets sent back to make the entire fleet of cars smarter and safer. And that really gets to the very heart of this SOTIF philosophy. The goal has shifted. It's not about chasing this impossible dream of a perfect system that can handle every single thing you throw at it. Instead, it's about building an honest system, one that knows its own limits and has strong, clear ways to manage its own imperfections safely. So I'll just leave you with this final thought. The technology is evolving at an incredible speed to be a better partner to us. The real question is, are we, as drivers, ready to understand our part in this new partnership and become smarter collaborators out there on the road? Thanks for tuning in.